engineers, electrical engineers, software engineers, verification engineers, all working together to make our projects. And we are doing our first projects in embedded Rust. So the team's historically done C, and we started learning Rust the start of last year. And we're currently writing some of our first production code in Anger for next generation sensor and controller products. And so here, all my interesting things, and the airplanes in the front coming from my hobby project, which I make a desktop war game for jet dogfighting, which is completely different, no software, all complex math for the physics simulation in nomographs, which is kind of old visual calculator format. And George Fisher's been the team I lead is growing kind of slowly. We just actually added 2 Rust developers in the last 2 months, and I think we'll have another spout of hiring in about a month or 2. So if you're interested in working in Rust, if you're interested in Rust and embedded systems, reach out and make the contact. I put together this as a kind of like my history in software, because I came as a hobbyist and then worked my way through school and such, and a lot of interesting things along the road. I got into extreme programming kind of early on, kind of 99 timeframe. Got to do some classes with Kent Beck and company. Was a really interesting period. And we've kept along with that. And nowadays we're actually doing mob programming. So the team is remote, but all linked together. And it's been a really great way of collaborating to make good projects. And so the meat of what we're hearing, we're going to go through 2 topics, the majority of here on test and commit-or-revert. This is an absolutely crazy process that some folks who were taking a session with Kent Beck came up with it. It was actually the people who were working with him who suggested this, and then they gave it a try and went off. But it comes out of test-driven development. Test-driven development is sort of rediscovered in software during the Chrysler project that led up to extreme programming. There's actually some history in software that says it dates back actually to the Mercury project. But in this, and it's probably not news to everybody, you go in very short steps where you add a test, run your test, make sure that they fail, write a tiny bit of code to make that pass, and then clean up and repeat. And just honestly, how many people are routinely using test-driven development in the area? Is this a common practice? Is this? I don't know if we can raise hands or something at this point.
We have some yeses in chat, and yeah, I got a few. One does XP.
Oh, all right, cool. Anyways, as I say, not news on this one. This one's been around enough to get some real traction. And it has some really nice advantages, right? You get yourself a focus on understanding and requirements. I mean, this is something the industry struggled with for its entire existence, is this marriage between what do we make and what do our customers want. Looking at test driven, I think you've got to think about your requirements all the time, because you're writing the tests that specify what you're going to make. And because you're working in these small chunks and you're working with the tests, you end up with this highly cohesive, low coupling system as a result. And I'm fond of the term executable specifications. I've actually worked on a project that was for an FDA regulated safety critical system, where we claimed the acceptance tests as our detailed design documents. Right, so it's actually a powerful way of saying what your system is going to do, and you know it's right because the tests bloody well pass. So important things about it, though, is working in these small increments. Not to say you think in a small increment. You may have a whole plan of what you're going to do, and you're going to have maybe a test plan. You write out what are the next 5 things I'm going to test, and I'm going to think about the requirements and stuff. But each step that you move along the way is much better off if you move just the smallest possible step. And this means that you're getting your feedback really quickly. Like you might be getting multiple items of feedback in a single minute. Or at the very worst, you're getting feedback after a few minutes. So it's almost like driving a car. Driving a car, you're constantly making small corrections, little things, you notice a little bump in the road. Oh, there's a piece of tire out there. You swerve around it. This is putting your software feedback at the fastest cycle you can. So you're seeing what doesn't work in the code, what's awkward, what is going to be in your way, and you're steering around it, making improvements, making cleaner things by having this exceedingly fast feedback cycle. And then refactoring goes hand in hand with test-driven development. Kent sometimes describes when you want to go and add a feature or fix a bug or any sort of change. The first thing you should do is clean up your code to making that change easy. And by the way, the process of making the change easy might itself not be easy, might be a little work, but then afterwards you make the easy change. So that's a close practice. So since this is an extension of TDD, I want to kind of step back and look at that. So test and commit or revert is a very similar practice. It's maybe an extreme version of test-driven development. In this, you add a test, you write the code, and you make it pass. You run it, and in this case, if the code passes, the code commits. The test fails, the code reverts. And this is automated. So in the command line that you say, run my test, you also give it the commands just like it says across the top as your script, test and commit. And so if the test turns out as a pass, it will commit. And if it fails, it's going to revert. So that's everything since your last commit goes away in one cataclysmic event. So anything unsuccessful, gone. Which is just nuts. And that's even what Kent said. So Oldmanstrom in this old thing, he was the guy who thought this was an idea. And Kent often has a history of saying he hates an idea, but if an idea wasn't crazy, somebody would have already tried it. That's what he chooses to try. That's how we got XP, how we got TDD, and now how we got test commit or revert. And this is just crazy pants, let's admit. You throw away the changes, it's completely wasteful. And how do you even know what went wrong in that code? I mean, it's gone, right? And how do you ever get anything done? And, well, it's not as bad as you might think. Like, throwing in changes isn't that big a deal, right? You do this all the time in software. That's where refactoring almost is. You're always changing code. And if you write a tiny change from scratch, then doing a new version from scratch takes you almost no time. And in fact, it's often faster than even figuring out what you did wrong. Because most of the time what you did wrong was, I put a semicolon in the right spot, wrong spot. I'm always writing let my variable name colon instead of let my variable name equal. Half the time I write that wrong. All right. And so if I just write it over again, I'll do it right. I won't even notice. I won't have to debug. And I won't learn anything from the fact that I put a semicolon instead of a comma, right? That's not going to help you. And figuring out, like I say, if you just, most of the time it's a bad keystroke, and there might be a time where you're doing something you've never done before. Maybe you want to turn it off at that point, right? If I'm off doing something I haven't done, well, okay, that's a different thing. This is really for when you actually understand what you're coding. And it turns out, with just a little bit of practice, this actually turns out to be reasonably fast. And the code you get out of it, I found, is pretty darn good. So it definitely enhances this idea that test-driven development works well with small changes. And this challenges you to write even smaller changes than you would have thought of before. It goes hand in hand with refactoring, clean code. If you want to be able to make a change and have it actually pass the first time, well, making your code understandable enables that. And so these practices reinforce one another. In fact, over a little bit of time, this can help you noticing all those little hints the IDE is throwing you. Well, what's that little yellow squiggly? What's that red squiggly? What is that? And so before you hit the button to test, maybe you want to sweep the screen and make sure you don't have any of those. And so these sort of habits become more entrenched by doing test commit and revert. And so tooling wise, right now I'm using CLion, and that's the tooling that we're going to look at tonight. But the original approach was just on the command line. So they did the command that ran their tests. So maybe this is a cargo test, and they're looking for the return code, right? The return code comes out 0 if you're fine, and you get a number if it's not. And then through the script, you just put it through the ands, and if it succeeds, you're going to do a commit, and that's just your normal get commit commands, and you're going to OR out to a revert, and that's your normal get revert, and you do it on one command line. So as I say, I'm using tooling in CLion. There's this thing called limited whip. It's not specific to Rust. It's just a plugin for the IntelliJ packages. What I really want to do, though, and I haven't figured out how to do it yet, it's just a matter of time, is Xtask in Cargo. It lets you build kind of extended command lines. And I'd really like to link something up with Cargo Watch. So just every time I save, it would go off and do this, run my tests, and either commit or revert them. So that's aspirational, maybe in a week or so. But for now, I'm using limited whip. And we're going to show one more thing today, and that's a little bit about coverage testing. And so coverage testing is a practice, set of tooling really, that goes through, and as you're working, it counts how many times something is executed. And it could be several different reasons why you might do this. You might count functions, you might count statements, you might actually count the different directions of a branch, right? Have you gone down each branch? And there's really extensive sets where you can test all the combinatorial paths that you have through your system, right? Did I go through the branch to the left, and then the next branch did I go through the right? And have I gone through all the right combinations? So you can do this on kind of a small scale. You can do this on a very large scale. And typically when you're doing this, the tooling builds out an annotated build. So something that collects data as your code executes and creates a file and a record, and then you can present that in several ways. There are tools that'll put this on a web pages with your whole tree of code. And there's tooling that will let you look at just the file that you're currently working in and seeing what the execution coverage is. And that's what we'll show today. It's useful to tell you, how are you doing on test coverage to begin with? But if you're doing a good job on test-driven development, you often don't have a whole lot of problems with this. But what you kind of might have a problem with is just self-discipline, right? Test-driven development it's a disciplined practice. And one of the things is to not run ahead of yourself. So oftentimes you're going to build some code, and you know what it's going to look like, right? I'm going to make some if statements. I'm going to do this while. I'm going to build a big data structure here. You have this whole picture in your head of what you're going to code, and you can go in and I've written a test, and then you write the whole thing, and all of a sudden you've got coverage for this much of your code. The rest of it's just the Wild West. And what you can do with look at test coverage, if you're looking at this routine needs, you can realize, listen, I just wrote something, and I wrote a bunch of code, and I've written way more code than I've written tests for. And maybe you should just undo back and try it again and work in smaller steps. And so it's helpful on that. Coverage metrics, some places use as a measure of how good is our code. This is a horrible practice, right? You should not try and drive a team to a number, because there's lots of reasons that you don't cover code, right? And there's some of it is just language things that are specific. There are actually unreachable lines in code. If you have that default at the end of the case, at the end of a switch statement, sometimes that default you can't get to, right? And then there's other reasons. You may want to tactically choose that I'm doing like an imperative shell functional core sort of design, and you want to test the whole functional core. And the imperative shell is often just straight line code, no ifs in it, no branches. It's just collect the data, put it into the functional thing, collect the answer, and set it down or hand it off to wherever it's got to go. It doesn't make any sense to necessarily test that straight line no changes, no decisions kind of code. So like I say, code coverage, horrible metric as I'm going to judge my team or I'm going to go judge my code base. Very effective in close as a tool for the individual developer. And inside of Rust, it is new. You've been able to do some stuff with gcov all along, but they have been incorporating a very good quality linkage to the code in the actual Rust infrastructure. It's currently a nightly, but it definitely works solidly. And it works in CLion just pretty much straight out of the box. So CLion's got the coverage thing, you just turn it on and pull down the build with coverage and you will get this. And so it's really easy to use. And it's either line or statement coverage. I haven't dug down enough to know the difference of it. Statement coverage would be if you had two statements on the same line, you can differentiate. And line coverage is just tagged to the line. But either way, either of those is actually pretty effective at helping you with using coverage to drive your tests. So, and I'll post this up, but I have some links that'll be helpful to you if you're interested in this. First few are about just Test-Commit-Revert, some original things from Kent, some thoughts on different ways of approaching it. And then the tooling we're using, Limited Whip, is here. I'm actually using a little variant of an assert library for Rust that I like. I'm planning on feeding some changes back to the original author here, so you're getting my version instead of my forked version instead of the origin, but it'll be back in the origin soon enough. And then the last thing is the Rust announcement about its code coverage tool, so you can kind of read about where it is and follow development as it makes its way to stable. And with that, that's my presentation part. And then what I thought we'd do is drop in to an editor and turn on TCR and write some code together. And I'd say we use mob programming in my world, so I'm actually happy if we'll let all of you come in and give me some direction on what code I should write, and we'll see whether we have to rewrite it or not. So
Awesome. Everyone should be able to unmute now so they can participate.
Okay, so we're going to do code kata on a circular buffer. So pretty straightforward, simple thing. The API for this, I should put a link up for the actual directions to it. So hopefully the structure of a circular buffer isn't alien to anyone. The API we're looking for is something where we have a function to get, a function to put, and somebody tells us whether we're empty or we're full, right? And then creation. In this, just from a planning perspective, get returns some sort of fixed value, maybe minimum integer, when the buffer's empty, and put returns a false when the buffer's full, and a true when it's not full. So anyways, you can see I've got one test here. One of the things, I haven't hooked up a string to this yet, but see all you do is here, say run testlib with coverage, and it will do its build and dump out some results here. And then it annotates what lines we got coverage. So I ran my entire test and it did execution through both my new constructor and the empty and full routine. So we've got real good coverage right now. The all asserts, the only thing that's interesting here is you have an assert true and assert false. They have less than and greater than and such. And I'm currently working on a near for working with floating points, which are things that, you can do other ways. And these things are just macros that call into the original assert equal and just base assert in the libraries. But I like them, and so use them here. So what do we want to test next? Anybody have any ideas? So for me, like I say, this is a reasonably common kata, and we've done a bunch on my team recently of this to evaluate different test tooling. So kind of the next tier up how we're going to assemble this. And so maybe one of the things is if we attempt a get right now, it should give us a fixed thing back. So it's a one of the things that's wonderful about mob programming or any sort of live coding is it makes a great show of how bad a typist you are.
I feel like about 10% of any TDD conversation is apologizing for bad typos.
Probably true.
Especially with new pairs.
Yeah. Some of the folks in the mob community talk about pairing as being a little bit like being on a blind date when you're with your new pair. Everybody's a little bit nervous and what's going to happen. And all right, so I'm going to create a buffer. I'm going to not hit colon, which is what I always do wrong. And then I'm going to say okay. So that's a is that going to pass? Pass a semicolon. I'll tell you that right now.
It looks like no.
And there's a squiggle. That's a good thing to look for. I suppose that squiggle's saying
Need a function there,
eh? Okay. Now, this particular test tool, if you write something that's not going to compile, it doesn't revert when you don't compile. And that's not bad. It helps you with the semicolons a lot more. I don't know if that's the original intent, but it's what it does. So you think that'll pass? Let's see any squiggles. That's a good sign.
Yeah.
All right, let's give it a go. Cool. All right. So let me just make a quick demo about what happens. You know, min. I don't like that. Let's change min. Let's refactor this so that this does max. And yeah, okay. So I'm gonna change the conditions, and I'm gonna rerun the test like that. And holy smokes, that's wrong. So come down here. It tells you the current change reverted. And like I say, a little slow with the transfer there, but you see the file gets reverted, picks up, and there we go. So that's the bad side, the bad leg of this. And one of the things that, like I say, gets a problem is, well, I know I'm going to get put, right? And what's put going to do? I want to put, this is, I'm not going to return blue either way. And I wanted this to return like true when it works and false when it fails. And since this is a 0 size buffer right now, oh, I gotta take a value in. I'm not gonna do anything with it yet. By the way, I'm using an interesting coding technique called zombies, which it's a good blog post by James Grenning about. And it's the idea that you work in the sequence of 0, 1, many, and then boundary cases, I forget the I, and exception cases, right? So you basically start with a 0 and then work your way to multiplicity, well, to existence, then the multiplicity, and then you work through all the bad cases. And so doing nobody's going to make a serial buffer of 0 size, but it actually helps you iterating through the API. And so, okay, well, let's go ahead and run that coverage and see what that says. And since it reverted, all my tests are going to pass, and no code's going to get reverted. But oh, wait, why is this red? And it's red because I wrote code that I don't have test coverage for. And so that's a hint to me that I went too far, and maybe I should Control Z my way out of that and go write a test for that instead of instead of getting ahead of myself. So I might conceptually just the little gutter on red 9, exactly. The coverage data is right here, and so everything that's green got executed in the test, and everything that's red is a line of real code that didn't execute during my tests. And so that's and you get viewers of different quality. I mean, some of them like cover up the whole line and they're really pretty evident. This one's a little on the subtle side. I'd like to hunt around and see if there's a little bit more in your face, especially for the red. But anyways, if you keep an eye out, it definitely will help you out. Or maybe if you're working in a pair, somebody will go, "Hey Phil, we're red. What's going on?" And then you go off and fix something. So what I do is in this sort of cases, I Control Z, or I'm going to cheat and do Control X, so I don't have to have you all here watching me type. Okay, now we're gonna fail because we don't have put. So I'm gonna go and retype that really quickly with the paste. And what do you think? Think that'll pass? String false. Okay, it's got the right man.
Put 42, return false. Yeah.
Yeah, but that's gonna go. Let's see what we do. Oh, great. Oh, we got coverage. We got passing tests. Huzzah. I'm getting a red for the hashtag test. That's not ideal. But
oh no. Your annotations aren't tested.
I don't know how to write code to test that yet. So I'll get into Discord and see if anybody knows. So cool. I think you were looking for about a half an hour, and then we're on the schedule to do next. I'm happy to write more lines of code and do more, depending on what people are interested in.
Yeah, I mean, feel free to take another 5 or 10 minutes here, and then we can talk a bit, I think.
Cool. I think that's actually a pretty decent API for size 0. So let's do something with size 1. cut and paste here. Okay. So getting rid of the null object and going into something that's got some size to it. All right, so we've got to go change the code up top to make this work. Let's see, I'm going to start by adding capacity, not 932, let's make it a U size. Keep aside the L. And let's see, delete that. And let's see, we said full's false, so it's no, it's capacity equals 0. So it's full and that's not the final implementation, but that ought to pass, right? Oh no, it won't pass. Red squiggle. You folks should be telling me red squiggle. Come on. All right.
Capacity use size is, it's unhappy about capacity at the top.
Let's see.
Oh yeah, should that be a comma?
Oh, comma. There he goes. Commas and semicolons. Don't eat your lunch. All right. Frankly, that should have a comma for future. But all right, let's give it a go. We got to pass. It's going to be true when it's the capacity is 0. When the capacity is 1, it's going to be false. Did I actually change the capacity in the test? That would be important. Cutting and pasting tests is always dangerous because you end up
Yep.
not changing everything.
Very useful, very dangerous.
Exactly. And it's false when it's full, true when it's true for empty, capacity 1. All right, let's run this bad boy. What else is an object? No, it looks like it passed. So hooray. And honestly, one of the things that I find is once you start getting used to working in really small increments, like I know, for example, that what I just wrote is the implementation for put or for full. I'm not going to use that. That's not going to last more than a moment. But having that smaller step is a really nice boon. Keeping yourself down to the smallest change helps you think through the problem set, helps you make cleaner code. So what are we going to do next? Let's actually do something with a put. Oops. Okay, so I don't really care what we're putting right now because I'm just checking the empty and together. Oh, I need space there, don't I? Okay. So, oh, I wrote the wrong capacity here, didn't I? Okay, so we're gonna put in, I'm just gonna do the empty change first, even though I plan on doing full. And then that means when I'm putting, I need to actually do something. So I'm gonna create a new bit of data called count, which keeps track of how many times I've put. Slides it to 0. Of course, I've forgotten self. The put becomes a little bit. No, that's not gonna work, is it? I probably need to do something where full is self capacity equals self count, right? And then I can say something like if not is full. So when it's full, I can return false. Sorry, the lag on the keyboard is a little distracting. I'll increment count. And I'll return true. Not gonna work? Oh, no, it won't. Why won't it work? Yeah, that is definitely why that's unhappy. And then now I got to find all the places where I've used put because they're not going to work, right?
Beautiful bee. Oh, just that last one.
I love it. Looking good.
I think
Oh,
so.
the squiggle went away on the B. All right. I'm actually doing a little bit more like checking the code than I might do since I'm here in front of all y'all. But let's cross our fingers.
We're trying our best not to get reverted.
And we're good.
Cool.
But like I say, being reverted isn't so bad. You actually get that sort of second system effect where writing something the next time
Yeah.
you can often get a little insight, do a little better. And So anyways,
Is-
that's a quick look at Test-Commit-Revert, along with a little bit of coverage testing. By the way, we didn't look again at coverage testing. We didn't do a whole lot of refactoring, which might have been okay, but we've got good coverage. So
Awesome.
that makes me smile.
Is this a good place to break for questions then? Just kind of chatting.
I'm happy to. Yeah.
I'll kick us off with questions because I'm curious, and then I'd love to hear folks can chime in. If it's in chat, I'll do it myself, but feel free to unmute yourself and ask. When you're doing Test-Commit-Revert, other than being incredibly small, are there other side effects that you notice in the way that you write code?
Well, as I say, one of the things that I've noticed is I use the IDE hints a lot more. I see them better, and yeah, they've become much more my friend than they ever were before. It definitely has. It's helped me with incrementalism, and there's points where I'm finding that I make, my eventual design and my eventual code is often more concise. I'm cognizant of these sort of, this is really, hopefully fairly easy to read code. This sort of, guard and then everything else style works really well. By the way, I picked up a book it's on manning early access right now called 5 Lines of Code, which is a text on refactoring. It's not released yet, but it's in that early access stage. Really nice little text on writing code in small ways. I didn't put it in the notes, but look for it. It's easy to it's easy to remember. 5 Lines of Code, and it's that style that they recommend is very compatible with writing code this way, and let you think about refactoring and I also, definitely this is nicely compatible with automated refactoring tools. And so you kind of want to make sure that you're comfortable in those and being able to move around quickly and easily with it.
Interesting. Anyone else have any questions? If not, I'd be happy to just kind of open up the floor, and I don't think we need to do breakout rooms with such a small group. We could just kind of talk amongst ourselves. Thanks for presenting. I really found this interesting. As a TDD person, it's like a very unique kind of style.
It just seemed absolutely crazy, when you first read about it, and then you do it for a little bit. You're like, oh, okay, this kind of works, and it's, there's a little bit that. Even when you first got into test-driven development, it seems a little bit like a game. And then I think maybe it scratches that itch where you're always kind of challenging yourself in your code and to make it a little more concise, a little clearer, a little better. So I think it definitely helps with that. And there's a thing that Bob Martin did that was a transformation priority premise, which is interesting reading and some talks on it there. And it's also one of those things that kind of helps with this style, the way that they suggest making changes. And I'm not sure how much people have heard this or not. Conceptually in this, refactoring is a change to code where you're modifying the structure of your code to improve generally readability, changeability, right? But you're trying to not change the functionality of your code. And so in this, we describe a transformation as the actions to actually make behavioral changes in your code. So conceptually, what you're doing as a coder is you're writing a series of transformations, getting yourself to a passing state, writing a series of refactorings to get yourself to a cleaner state, iterating back and forth. And in this, Bob postulated that there were better transformations to write, or smaller, cleaner transformations you could write. And so when you went down, if you said you just introduced something that was sort of a null item, that would be simplest. And then when you add something that has actual value, that's slightly more complex. And when you add something that has a variable, that's more complex. You add branching into your structures. That's yet more complex. Somewhere down there's assignment, right? If you're changing a value, that's really bad complexity, and switches and stuff. And so there's a hierarchy that he's postulated is in increasing order of complexity, and you should work in your highest simplicity. And like I say, this is another thing that it kind of helps you thinking that way. If you think about that sort of list in your head, what's the next transform that I'm going to do on the code? And then you say, what's the smallest transform? And so this is part of why I'm sitting and writing a circular buffer that with a capacity of 0, is because that's actually the simplest form of this. And it let me think out. I mean, I've got the whole API done here. I mean, most of this code's bollocks, right? You're not going to really use it in the end. But I know this API, and I know the API works, and it's comfortable to code with it. I can use it to do stuff with. And so working in these sort of simplest, and then becoming increasingly complex and increasingly specific is, or increasingly specific in your tests is, kind of complementary to this style.
Cool. Well, thank you so much. Why don't we just open it up and do introductions for anyone who wants to stick around and chat. Me and Cameron have already and Phil have already introduced ourselves. Does anyone else want to introduce themselves? Tell us what they're doing and what their experience with Rust is.
Hey, I'm Brock. Rust a little bit at work. We have a WASM project, WebAssembly project that's written in Rust that we use. And yeah, been writing it for a couple of years now, but I'm definitely no pro.
Where are you coming from into Rust?
Oh, do you mean like what languages?
What languages? And yeah.
Oh, gotcha. I mean, lot of JavaScript into the Rust, but my background was embedded system stuff, like way back in the day. So yeah.
Someone else want to go? I can talk all day, so. How long have you been doing Rust, Phil?
I came kind of back to it about a year and a half ago, and it's just been sort of bootstrap learning it, and then actually using it for production code started October-ish.
Okay.
So we actually brought Jake Goulding from Integer 32 over to give us a course for a week early last year, and then because we've got a bunch of folks who are longtime C programmers, we're just kind of stumbling into it. We hired some folks from a place called Ferris Systems over in Berlin, and so most days Jorge Aparicio spends his evening, 4 hours of his evening with us, mobbing with the team, and so our mornings are with Jorge or Fed James Buns and Jonas Scheinig in helping us over the embedded concepts and Rust concepts. So keeping the team focused and moving through that, which has been, really cool on the whole. So you got some really great people, and we're actually doing practical stuff on the real device. So it's great.
So here's the thing that I feel like I haven't written enough Rust or like done it enough professionally. I'm curious what people's thoughts are on like how the pattern. There are some things in Rust that I feel like really feel great and look great and they encourage me to do good things. But there are still places in Rust, in particular, like some kinds of guards that I want to do and stuff like that, I feel like are hard or not ergonomic to write in a way that sort of looks clean. Are there things that you feel like are still kind of rough edges when you're writing Rust compared to the readability or ergonomics? I know somebody mentioned async.
In the code that works with WebAssembly and interfaces into web APIs, like browser APIs, the actual like conversion layer is really good, but once you get something into that, like a DOM object or something like that, into Rust land, it can be a fight to handle it correctly. And that especially comes into play with callbacks or any kind of events, in terms of like, in JavaScript, you're just passing around functions all day long. And you're not worried about like storing references to them or like passing things or shared pointers or anything like that. And like, but once that's in Rust, you have some really nasty like types and lines that are like, as ref, mutable, like borrow, mute, whatever, like keep going. So that can be a little hard to get used to. But once you figure it out, you just wrap it into a function and never look at it again. And like, now you're good.
Yeah, well, and that's definitely a two-edged sword, right? You have to suffer for it, but on the other hand, you're actually getting control of it, which is, a powerful thing. And having, for me, my career's been mostly C++ and lots of down at the register, on the middle kind of stuff, and being actually able to know that I've got only one accessor coming into something across this shared system is really marvelous. And honestly, when I was writing medical stuff, C++ terrified me. Right? You just, honestly, it's not, I never felt it was like a responsible language to use, but it was the best thing you had. And the only other choice you might have had was maybe Erlang for a long time, and Erlang just didn't have enough tooling support. And even then, it didn't have that kind of memory protection. So like, this is, like I said, the first thing I would feel responsible putting into that kind of safety critical device. I mean, I shouldn't say I'm not irresponsible. Medical systems, there's lots of checks that go on afterwards to make sure that it's as safe as practical. But this is just so much better. It's so nice.
Phil, I had to ask you this question because did you speak at an SCNA a couple of years ago? Was that
Yeah,
you?
2017, I think so.
Okay, yeah, because when I started reading your bio, I was like, wow, I swear I heard this guy talk before, and then I went and looked back at the SCNA conferences, which those have been fantastic, and I miss them dearly. But
yeah, it's kind of sad that they, the man in craftsmanship, knocked them down first, and then Eighth Light got consumed, and that was kind of the end of it. So, but yeah, no, and you can go up to softwarecraftsmanship.org and you can find that talk on it still, I'm pretty sure.
yeah,
So,
and you
well,
were
cool.
the embedded stuff you were, yeah, the embedded stuff you were doing was like respirators, and that was pretty performance critical stuff.
Yeah, those were definitely sacred. In that talk, I had a slide. I actually have a picture, and it's just a big set of graphs on it. But it's the first patient that software that I led actually helped, and so it was just really cool working in medical for quite a few years, and knowing you were doing things that were really helpful, and we had a great team, and we made some crazy clean software. We ran that whole thing was all a zero bugs approach. So, and when I came into the company, I went on to systems we were sustaining that had hundreds of known bugs. And I guess that's not uncommon in that world. And we're like, that's not how we're going to live. So we did a whole, process transformation, lots of learning, lots of teaching, moving into extreme programming, test-driven development heavy. And I'd say, I think we made products we were really proud of. It's a lot of fun.
Say more about this zero bugs approach. I've never heard of that.
Zero bugs. Actually, sometimes they write it ZARROBOOGS, zero bugs. And frankly, it's because there was some Jira equivalent tool out there that when you had nothing in it, that's what it wrote. In humor, right? Or misspell it. And frankly, zero bugs is just what it means. Run your system, and anytime you find a bug, you fix that as your highest priority. Somebody stops feature development, goes and investigates the bug and fixes it. And once you get into kind of a continuous delivery sort of model where you've got full set of tests and you're constantly in a state where you're ready to release, you can't live with your CI tests if you have bugs, because every day when you go read your CI results, and when we were doing this medical system, the whole test suite probably took 40-ish hours to run. And so we parceled it up over a bunch of prototypes, right? The prototypes were expensive, so we only had a few of them. And it would run overnight, right? At 8 o'clock it'd turn on, and 6 o'clock in the morning it would stop. And when we got in, we'd all collect together and look at what the test results. And if there was anything found, you'd say, well, that looks like a GUI thing. Marcy, you go work on that. And you go hunt it down, and your goal was to have it knocked out that day. And most of the time we did. And occasionally we found things that were hard to fix and hard to find or hard to replicate. And those bugs had to hang around for a little while because you couldn't get them to repeat and guarantee enough information. And that drove us crazy, and we hated it. But it's the nature of the world. But if we couldn't fix it right then, you were obligated to figure out some instrumentation to catch it the next time and get yourself more data. And we found all kinds of things. We found places where the hardware that we were developing in-house broke. We found bugs in the processor that TI provided us. We had a bug that every once in a while, and this is like on maybe a month, you'd come in and the screen on the ventilator was black. And you'd be like, oh shoot, the thing locked up, right? And then you'd log in with the debug proxy, and it's running. You're like, oh, what's going on? And so then you go and grab the screen buffer, right? So you can go do a poll of what the screen buffer was for the LCD, and there'd be something there. And you could go interact with the buttons, and it would change. You could go get new updates. You're like, what's going on? And it took us about 6 months to run that bug to ground. And we figured out that something in the graphics driver of the chip was resetting itself. And so we had to basically go in, and every n seconds, we just went and reset the graphics driver. And we told TI about us, and they denied that no, there's no bug. And then a service announcement came out with the workaround for the bug, which is what we found. And so, but zero bugs just means what it says. And it's like when you're on an existing system and there's 100, 200 bugs, okay, all you can do is whittle away at that slowly, right? And, because you still have to keep delivering functionality. But once you get to the point, or when you're starting a system, get your CI/CD system running day one, and look at the thing every single day, and prioritize fixing the bugs, and then you'll stay at zero. And so every time you come and you see a bug, it's new, it's real, and it's not that, oh, I see something and oh, that's that thing we saw, right? Oh, that's not important. Okay, and pretty soon you've got this huge list, and you can't look at your thing and even recognize when you have a new bug. Right. And so that's the kind of the idea behind zero bugs, is you want to make it so your test reports are meaningful. So you can find some articles like Arlo Belshie's written on this approach. And I think some of the Hunter folks have written some stuff on it. So the folks doing the kind of mob mentality show and such, I think there's been some stuff on there. Yeah. Well, that's the fun part, right?
Welcome.
Hello.
Hello. I actually have a question. How does Rust cooperate with the like C++? It seems we don't have a lot of, established libraries.
So I've only done a little bit, and most of it directed to C. But C and C++ are of the same call model, and it's just links. There's first off, there's some macro packages out that will help you generate header files off your Rust code, or will bring in a C header into a way where you can call it in Rust. And then once you've got that, it's dead transparent, right? They interact really nicely. There's two different ways you can set up building. And one is basically you're integrating C code into your cargo and building it the Rust way. And the other way is you can take your Rust and compile it out of your make file in your C. Kind of depends on which one you have more of. And one of the really nice things is the debugger plain doesn't care, right? Debuggers, and this is not a Rust feature. This dates from way back. In the ELF file, they basically just have file and line number annotations for all your code. And so when you go and say, I'm going to go do debugging, and you're single stepping through, if you're single stepping through a Rust file and it calls a C function, it just boom pulls up the C code, and you're in it right at the right spot, and you step, and then bang, you're back to the Rust code, and vice versa. So it just works.
That's
so
cool.
It's pretty darn smooth. I've read some things that say some of the modern C++, some of the things in there are not, you don't have the easiest call to, but I've never dug into it. I mean, all of where I'm working now is an old C house, and they literally have no C++ code except on one project. So that's what's all C, and it's really easy.
I mean, I mostly work in using C++ only, and have never written any Rust code yet. But I've heard a lot of good things about Rust, so that's why I'm here. This is actually my first encounter with Rust.
Oh, cool.
Welcome.
Yeah.
I-
If you're writing classic C++, C++ 2003, MISRA 2008 kind of stuff, the interop is straight up right. It's really easy at that point. And like I said, I haven't explored the modern C++ setting in that context.
We mostly use like latest C++. Right now in our work environment, we use C++ 17. So.
Oh, cool.
Yeah, I've been toying around with, there's a game engine called Godot that has bindings from Rust. They use bindgen and all that stuff, and then they've really fleshed out the bindings really nicely, which is really exciting and really cool because I've been wanting to write games in Rust, but I haven't really been wanting to do it from scratch. And the only thing is, I mean, it just, you're walking over the line from a really safe language to an unsafe language. And so the Rust right on the boundary looks pretty ugly, but it's really just representative of how unsafe the C++ code was. And of course, sometimes the actual marshalling across just makes it less safe and less clear how safe it is. But other than that, it was extremely fluid.
What's like the position of Rust in GUI, in rendering kind of domains? Like, are there like very mature libraries, wrapping OpenGL, SceneGraph, or whatever game engine, such that people new to Rust can start doing work without rebuilding wheels from the scratch?
Yeah, my experience has been that everyone's using wrappers around other, UI and GUI libraries. Like, there's some fairly mature wrappers around OpenGL. I wouldn't say they're perfect at all, but there's fairly mature wrappers around OpenGL that are very usable, and people have shipped games, a couple games with them. not a ton. And as far as like UI, there are a couple of UI frameworks that are kind of building right now, but I think that most of the stuff that's more mature or whatever, they're using a wrapper around what's the big Linux UI framework that I'm just drawing a blank on? GTK, yeah. Yeah, just put it
I
in the
mean,
chat.
even in C++, GUI, especially portable GUI library, is like a mess. So there's no great one solution for C++ programmers to write portable GUI applications. I mean, I don't know about Rust story. You know, if we have something like this in Rust, it's going to be a huge attraction point for people, right?
So you can definitely target like all the platforms with Rust, just kind of like you can target all the platforms with C++. Now writing like a single GUI like button that translates to all of the things, that's kind of a different case. But like I've written basically I've written Rust code that directly targets Mac GUI stuff, and like the bindings worked great. Like it was cool. And even I was even able to get in there and write some metal shader code and like pop open a window and like bam, there you go. And like that's all from straight Rust. There was no, this is command line and like built with Xcode. I didn't have to open up Xcode. And to be perfectly honest, the story with Rust to browsers like is really, really good. So I've heard of people using things like Electron, writing their code in Rust, shipping it with Electron, and like it works everywhere. So that if you're looking kind of like cross compatibility, like browsers are really good GUI APIs.
Oh yeah, and portable, right?
And portable, yeah. Just depends if you want to use it. Like that's a whole other thing.
There's wrappers around Qt as well, which are about as good as you can get in C++, right? Is for cross-compatible UI.
Qt.
But all the other cross-compatible code you want to write is going to be way better in Rust than C++. That's my experience. It's been very, very nice. If you're just trying to write command line stuff, but you're interacting with the operating system and files and all that stuff, C++ is theoretically works across them, but the standard library stuff is quite unique in Windows land.
Yeah, at work we have one project that targets browsers, it targets Apple iPhone, like iOS, it targets Android, and it targets Windows and Mac. And like this one code base gets compiled in a build process to all those targets, and it's currently running on all those targets. So it's kind of like, it's a smallish library, and it doesn't have any GUI code, but what it does is it renders things really well. And so we're able to write all our code that renders the exact same way and then just port it to all these different things like within a build process, and that works really well.
So in your case, at which level do you shield the differences of these different operating systems?
So we have we basically have a core library with the core code. And then on top of that, there's some like binding layers that then get built in the build process to target the core. So like for the WebAssembly stuff, we have like a binding layer that like I can instantiate objects and I can call functions at that layer. And then that layer calls the core code, and that core is shared. The binding layers are targeted for each ones, but they're all in the same code base basically. And like you don't really, and it's all written in Rust. And through the build process, it just knows which direction. In the code, you can do like a really good targeting for different systems, and you can use like all kinds of flags and stuff like that. So
it's like you are providing the implementation of the binding interface for different platforms. When the core part calls a binding, it uses the same interface to call the binding. But on different platforms, you provide different implementations for the binding.
Yeah, basically. So like when we target WebAssembly, we have to store a lot of the actual information within that binding layer, because the process of moving memory, like shifting memory between like basically JavaScript and WebAssembly, takes a lot of time. So it's not performant and to like serialize and, you know, as Drew said, marshal essentially, and like this information across this barrier. So we kind of have to store it in like there and then give a pointer back to JavaScript to do operations on it. But in other languages, they are assuming in other platforms, they don't have that issue at all. So like there's no issue, like whenever, because things get compiled, they're just shared basically. And so there's no marshaling.
I see. So basically your binding layer exposes some opaque objects for JavaScript side to call, and the JavaScript side does not need to know the details. They just use that contract interface to ask the binding layer to do the work.
Yeah, pretty much. Like JavaScript is kind of a very unique case in all of this because of the whole WebAssembly aspect of it, which is basically just like you said, it's a very like small opaque layer of pointers that are pointing to things in memory, basically for WebAssembly to then deal with. But the other platforms, that's not the case. The other platforms, it just gets compiled basically into you know, a package and they deploy it.
I mean, I'm from Apple, so I work at Apple, but I have zero position to say anything about Rust strategy at Apple. So this is just my personal interest. I mean, I have been writing C++ for like 20, 30 years. Just feel like, you know, you get to see all the greatness and, you know, the traps in C++, and just feel like, you know, maybe this is the time to look at some new language, maybe starting from hobby projects. No idea about Apple's strategy in Rust. I got to see that Google is starting to support Rust. Maybe the big techs will catch up soon.
I have a
Is that little IoT thing they've got done? I'm not remembering the name either, but yeah. So on the subject of C++, the reason kind of I'm here is, you know, similar to you. I've written C++ commercially since 92, 93. And this is the first thing that I think that actually can supplant it, right? You can do everything you can do in C and C++ better and safer, and right. And you know, it's not perfect, but it's pretty nice. And like I said, it's over the years, you know, I've enjoyed C++. I've gotten a lot of projects done in it, but it's just it's grown from kind of having a love-hate relationship to just a hate-hate relationship, and it's time to move on from the abusive girlfriend and into something better.
Is your video on?
Well, we chose Rust because we were all using different languages as our main languages for a long time, and all really afraid of screwing things up in C++, to be honest. Like I haven't touched C++ in like 10 years probably. And the case kind of at the organization was that too. Like we had a lot of C# developers. We had like some Go backend developers. We had people writing in Java and, Objective-C for different platforms. And, I was doing a ton of JavaScript at the time. So it's like all of us haven't touched C++ in forever. And we're all just like this is going to bite us. Like we're going to screw something up with C++. What's an alternative? Well, what about Rust? And so that's how we started with Rust.
That's really cool.
Sometimes we don't get a choice, For our domain, we are working in computer vision, and we are pretty much stuck with C++. You get, Java doesn't work here. It's too slow and it's unpredictable. C, it's like too much repetitive code. You don't have template. It's awkward to write object-oriented code in C as well. C++ is still the good balance between the expressiveness and efficiency, right? The trade-off. And Rust maybe it can catch up. I have seen some benchmarking results that Rust is mostly comparable with C++. However, the community, the libraries, it's just not like catching up enough in the ecosystem. So if you want to do something in computer vision and you are like starting almost like a zero, it's totally not comparable with whatever you already have in C++ in terms of existing libraries, for example.
Yeah, we're somewhere in the early adopter phase, right? It's past the pioneer phase, which was what, probably kind of ended about 2 years ago, year and a half ago, where the sort of 8 years or 9 years before that was pretty crazy by the look of it. And kind of since at least edition 2018, it seems like it's gotten fairly stable and there's enough ecosystem where people can really use it and get good stability out of it and be responsible using it at their company, right? Before then, if you were using it, it was, right, I don't think you were necessarily responsible at that point. Fine, there's points using it in that kind of case, not that they were wrong, but if you want to say, I'm going to have something that I can be stable and somebody can come and make a fix to this 5 years from now, 8 years from now, Rust is in a state where you can do that. So it's like a responsibility, but it's definitely in that, like, the pioneers are out in like this much, and the early adopter, you're kind of in this phase, and then you've got the sort of mass use, and then you've got C off in that tailing off, and C's kind of in that mass, C++ is in that sort of mass use and making its transition towards the end use, the late users kind of phase. And okay, at that point you have to live with, you're going to have a thinner ecosystem because there just isn't the mass and there isn't the history built up. And like, it's really only been stable in that sense. I don't know. I mean, I didn't have much of that perspective from the 2015 to 2018 period, but it seems like the 2018 edition, like they added the new borrow checker and stuff got kind of stabilized in there. And that seems like it's been a pretty stable system since that point.
The language also just got tremendously easier. It was around that time when they added the non-lexical lifetimes, which was just I worked in it from 1.0 until 2018 edition, like, a couple hours a week as a hobbyist. But anyways, I need to get going, so I'm gonna have to shut down the meeting, but thank you all so much for coming. I'm really excited. Next month, second Wednesdays we're doing April 14th. We're going to have Andrea Piscino, who's one of the founders at Ready at Dawn Game Studio, and he's been pushing hard for Rust there for a couple of years now, and so he'll be coming in and talking about how they're using it over there. So that should be another great talk. Thank you all for coming out. It was really exciting to hear about TCR, Phil. I appreciate it. Have a good one.
Thanks.
Thank you.
Appreciate
Thank you
everyone
for
listening.
presentation. Yeah. Bye-bye.
Yeah, please do. Thank you. Bye.
Okay.
Bye.
Bye all.